Here we go. We're working on this together. Can someone tell me where we're starting with?
3, sir.
3 moles of hydrogen. And this is going to be a one-step problem because we're going from moles to moles. So 3 moles of hydrogen. I'm going to draw my one little line there. That one little line means one step. And since I start out with moles of hydrogen, that's supposed to go on bottom. Moles of hydrogen should go right here. And then moles of what should go on top? Moles of N2, right? Oh, okay, NH3. Why'd you choose that? So if I said like 6 sandwiches, how many breads? You did like 12, right? Because that would be 6 sandwiches would be 12 breads. You understand how this works out, correct? You don't like your answer isn't about the number of pickles you need. I said bread. You answer bread. Agreed? So it's the same principle. How many moles of H2 are we talking about here? 3. How many moles of NH3 are we talking about? 2. Multiply this across, divide. You got the answer should have been 2 moles of NH3, and the number of sig figs is correct here. Raise your hand if you got this question right. What can I assist you with in this question? We set on this? You feel confident? How about let's say you work on maybe question 2, which is a 2-parter, a 2-for-1 special problem, just like your homeworks tonight. Work on question 2. They both begin with the if. Well, they actually all the sentences begin with if here, so I can't really distinguish them between that. But these 2 questions right there. Let's do this real quick. It says if you give 4 moles of KClO3, so let's start out with 4 moles of KClO3. Now, since we're starting out with moles of KClO3, what's got to go on bottom? Moles of KClO3. Now, someone raise their hand and tell me, does this cancel or not? The answer would be yes, it does cancel, right? How many moles KClO3 are we talking about here? 2. Where'd I get that from? Yeah, coefficient, 2. What are we going to? Moles of what? We're going to moles in this case of O2. In the top one, we're going to O2, right? Because it says how many moles of O2, right? Okay, how many moles are we talking about in our reaction? 3. What is 4 times 3?
12.
Divided by 2.
6.
The answer here is 6 moles of O2. Raise your hand if you got this right. This is a Go Mustangs kind of event right here. Okay. The next problem. You're starting out with what? 4 moles of KClO3. We know that since we're starting with moles of KClO3, we need to put it down here. And what are we going to? KCl. What number should go on the bottom here?
2.
2, because that was in our reaction. What about on top? 2, because that was the number in front of KCl. 4 times 2 is 8, divided by 2 is 4. So this answer is 4 moles KCl. If you would please put your heads down on your desk and cover up your eyes. You ever done that thing where like you don't hang out with someone for a while, you know, and you start to miss them? I do that every once in a while with my one friend that I have. And so I think it's time for us to revisit that friend again, and his name is molar mass. It's time for us to do a little get together. We'll take him to CC's Pizza. We'll take all my friends. Molar mass. Good? Let's remind ourselves what this represented. If we think about it, the molar mass was something that represents, it's a number that represents the mass in 1.0 moles of a substance. Thank you. Now, if I said that I wanted 1 moles of any substance in the world, do you know what you have to do? You have to find its molar mass, right? Yes.
If the number divides out to be a weird number, do you put it in a fraction or a decimal?
Decimal. Okay, decimal. Okay, so let's work on finding the molar mass. I'm going to review you on how this works. Okay. So here's like an example problem for you, real quick. Example. The example is H2O. That's something that's pretty simple. Let's find the molar mass of H2O. First off, how many H's are we talking about here? 2. And what's the mass of a single H? 1.008. Where do I come up with that number? Our table. Plus oxygen. How many oxygens are we talking about here? There's just one. Times what? 15.999. And that should come up with a number of grams, right? And in fact, that should come up to 18.015 grams. That is equal to 1 mole. And that's for water on each side. So if I said I want 1 mole of water because I'm thirsty, how many grams did you go get? 18.015. Agreed? I want 1 mole of water. How many grams do I need? Not all at once, please. 18.015. Makes sense. Okay. Let's make it a little bit more complicated. Ready? I want you to find the molar mass of CaNO32. Let's say you have 30 seconds to figure it out. CaNO32. I was able to discern that there was about 164.094, give or take, I'm off a little bit, grams of CaNO32 equal to 1 mole of CaNO32. Correct? So Sam, if I said I need 1 mole of calcium nitrate, how many grams would you grab me? Nope. If I needed 1 mole of calcium nitrate, how many grams would you get me? 164.094 grams. Dude, let's just understand concept right now. I'm gonna reverse it real quick. You ready, Kevin? Let's say I had 164.094 grams of calcium nitrate. How many moles do I got? 1 mole. Ready? I got 1 mole of calcium nitrate. How many grams I got, dude? 0.094, right? Grams of calcium nitrate. We set on that? What if I had 1 mole of water? How many grams I got? So if I had 18.015 grams of water, how many moles I got? We good? Do you see the trend here? I'm going to set a stage for tomorrow. You ready? This is your last piece of the notes. This is a reminder, a fact that we talked about before. That's the number 1. Nice and official. That looks like an I that's crooked, but it's the number 1. 1 mole equals the molar mass. Before you go to bed tonight, I want you to repeat this to yourself about 25 times. I think that would be sufficient to get the point across. Maybe 30. 1 mole is equal to the molar mass. Good?